Okay, the template is one thing. Let's start making some examples. A classic one is summing all the numbers in a list of numbers. We have already data defined a list of numbers, so we can jump straight into defining the function. The function is going to be named SumList, and it will consume a list of numbers, producing a number. So this is a function that consumes a list of numbers and produces their sum by adding together all the numbers. The header for the function is also pretty straightforward. We say that it's SumList, and it consumes a list of numbers, ... Notice how I abbreviated a list of numbers as alon. This becomes more common as we start writing longer programs and want to conserve some space. After we've written the signature, purpose, and header, we write some check expecs. So, the sum of all the elements of an empty list is 0. The sum of the other list we wrote before, called 4 elements, is 15. We just did that math. Now we get to go write the body. We begin by pasting in the template that we had before. So we go up here, we get to copy all of this code into our body. Great, saves us some time. But we still have some blanks to fill in here. So, first, we'll replace a list function with the more concrete SumList. This always mirrors the name of the function that we defined. And then we can look at the base case. So, what should this function return when someone hands it an empty list? Well, the sum of the numbers of an empty list is 0. If I have no money in my wallet, I have $0. Now, what about the recursive case? Well, we have the first of the list, which we know to be a number. The first of a list of numbers is, by definition, a number. Then we also have this expression, the sum of the rest of the list of numbers. What does that return? To answer the question, we look back at the signature of the function. The answer is that the SumList function always returns a number. Intuitively, we are saying that we want to get the sum of the rest of the list. That's insane! We're in the middle of defining this function, and we already want to start using it. We must take it on faith that this recursion will work. But if we do, we can save ourselves a lot of work. The only thing we have to figure out is how to combine the current element, the first element, with the sum of the rest of the elements. The answer to that is just plain old addition. With our function completed, we can now try running it. And assuming we didn't make too many mistakes, we have left a list in here. It should be alon. Same thing down here. Anywhere we used a list, we should actually be writing the name of the parameter alon. So let's fix that up. And there we go, both of our tests passed. Now, when our function runs, a lot of work is going on. For the first time, the code we're reading here on the screen is hiding a large amount of work happening behind the scene. Our SumList function is called once for each element in the list. If you have a list of 1,000 things, that means the SumList function has to be called 1,000 times. You now have to think very critically when reading code.